Hey friends, did you know that MongoDB and Azure are really great friends? I'm Luce Carter, developer advocate here at MongoDB, and today I'm going to show you that they are. I'm going to show you how you can really easily deploy a MERN stack Node.js application to Azure App Service, all for free. If you prefer a written tutorial, you can find a link for that in the description below, and this can be found in our Developer Center where you'll find a bunch of great articles for different tech stacks and languages. So let's get started. To follow along with this tutorial, we're going to need three things. A MongoDB Atlas account and database cluster, the free tier is enough. We'll also need an Azure account so we can deploy to App Service. Finally, we will need to have the MERN stack Azure deployment example forked to our own GitHub account. You will find the links for creating an account on both Atlas and Azure, as well as a link to the GitHub repo in the description below. MongoDB Atlas comes with database level security out of the box. This means it limits not only who can access your database, but also where from. So we will need to configure network access rules for who, or in our case what, can access our database. So we can go into network access, and we can start configuring it. There's different options here along the top, including peering and private endpoint, but the most common and simplest technique is using IP address. So you've got different options here. You can either add your own current IP address, or a different one. Since we don't know what the IP address or range of IP addresses will be for Azure App Service, we can't specify a specific IP address here. So instead, we're just going to give the access from anywhere IP address, which is 0.0.0.0. Now, I've already got this configured, so it may not do anything. If you go ahead and do that, you'll then see it listed here, which you can see will mean it includes your current IP address. Now, we don't necessarily recommend doing this in production because, of course, this does allow access from anywhere, but it's really simple for just getting started and a simple demo like this one. Before we get started deploying our MERN stack application to Azure App Service, it's probably a bit good to cover what the MERN stack is. MERN stands for MongoDB, Express, React, and Node, and is named after technologies that make up the stack. MongoDB is a general purpose document database for storing the information. Express is a Node.js web server. React is a client-side JavaScript framework for creating UIs. And Node.js is the most widely used JavaScript implementation. And you can see how this all goes together here in this diagram. So let's have a quick look at the GitHub repository that we're going to be deploying. Here we are in GitHub, and you can see the repo that you will have forked in front of us. So it's got a README that just talks about how to run it and things like that. Don't worry too much, and there are some differences. We're not going to go through the code too much here, just because you can actually learn more about the code and how to recreate it by following the MERN tutorial article, which is actually what this is based off of. But if we just go in, you'll see that we have two parts to this, the client and the server. So the server is just an Express app. It has some routes for the basic CRUD operations, and in the DB it controls a connection to our MongoDB Atlas cluster. One thing you will note is that it uses environment variables for our URI connection string, which will matter later on in the next section when we deploy it. As well as that, we've also got the client side, which is our React UI. So it's just made up of some basic components and an app like you'd expect in any React application. Again, if you want to have a look at the code in more detail, a link to the original tutorial will be in the description. But once it's deployed to Azure App Service, this is what it will look like. You'll just have a very basic, empty to start with list of employees. You can go ahead and create a new record. So we can add one. We can say I'm a developer advocate, say I'm junior. You can then go in and edit existing ones or delete them. So we could say maybe give me a promotion, or decide to just delete me altogether. So again, it follows the basic CRUD operations, and this is what we're going to deploy to App Service in the next step using our GitHub repository. So here we are inside the Azure portal, and we're in the App Services resource. Now you may not have existing apps listed here, but what we want to do is go ahead and click Create in the top left, and you'll see that there's three options for what you create: a web app, a static web app, or a web app and database. We want to select web app. This will go ahead and open a wizard, and then you can start filling out the boxes. So if the resource group pick whichever resource group you want to use. Then we want to give our web app a name, and it has to be unique because that's what's going to be used to generate the website. So we could do MERN stack example Node.js. That'll work. There we go. For publish, we're going to keep it as code. For the runtime stack, we're going to pick Node 16 LTS because I know that works first time with the application. Then for operating system, leave it as Linux. Then for the region, pick whichever region is closest to you. For the Linux plan, you can leave it as F1 if you've got a plan already. If not, it will allow you to create a new plan. But F1, the free tier, is more than enough. Then we want to go ahead and click Review and Create. This will just give it a second to validate everything you've entered, and then it will give you the option to create it. So click Create, and then it will go ahead and spend a few minutes just deploying your application. So once it's all deployed, you'll see a screen like this with a nice green tick and the ability to click Go to Resource, which we will do now. So the first thing we want to do is to configure our new app service with our connection string. If you remember from looking at the code in GitHub, we saw that the connection string for the database connection is got from environment variables. And the way app service works is that you use configuration settings and application settings to specify those environment variables. So on the left, under the settings heading, you'll find something called configuration. If we click that, it will load a new screen, which will allow us the ability to add application settings or connection strings. Despite the fact that in Atlas what we're adding is called a connection string, what we're adding here is an application setting because it was viewed as an environment variable. So we'll go ahead and click New Application Setting, and in the name of it we're going to give it the name Atlas_URI in capitals. Keeping this as that value is really important, otherwise your code won't be able to find it. In the value, we're going to go ahead and add in the value from our connection string in Atlas. If you're not sure how to fetch that, inside of Atlas for your cluster, you'll see it here. You click the connect button next to the name of your cluster. This will bring up a modal box with some different options. If you click drivers and just leave it as the default, if you scroll further down, you will see that there will be a step for add your connection string, and that will actually give you the connection string without the username and password in it. And on the right, you'll see a little button to click copy. So go ahead and copy that and then paste it into that box, substituting it for your own value, and then click OK. To save myself, showing my information here, I'm not going to do that step, but as once you've added the value, all you need to do is click OK, and then it will look like the step that you'll see in a second. Once you've fetched your Atlas connection string and pasted it into that box inside of the Azure portal, and of course replace the username and password with your own values and clicked OK, you then need to click Save up here at the top, and then you'll see a screen that looks like this, where you've got your Atlas URI name and the value is hidden. So we've created our Azure App Service and we've added this Atlas URI, but now we actually need to link it to our GitHub repository to take advantage of the CI/CD goodness available. So here on the left inside of the Azure portal for the app, you can see that we have Deployment Center. So if we click that, you'll see that a window opens under Settings, and the first thing we need to do is select our source. So in this case, we have a few options. We're going to be picking GitHub. You then need to fill out the boxes to pick your application. So I'm already signed in to GitHub. Then for the organization, I'm going to pick the demos organization. Select the correct repo, in this case it's MERN stack Azure deployment example, and then we want to select the branch. Under the workflow options, we want to make sure that the add a workflow is our selected option. We are going to go ahead and edit this file shortly, but we do want to make sure that it is added. Then we're going to go ahead and click Save. This will set up the deployment inside of GitHub Actions. Great. So we've connected them up, but this will actually trigger a build, so we do need to wait for that build to finish. If you view this on GitHub, you will see that it fails though. So we've added this connection inside of here, but the build is actually happening as a GitHub action inside of our forked repository. So if we go back to it now and we have a look at the GitHub Workflows file, you will see that it's added a file for the example that we just added. So if we have a look at actions, it will automatically trigger a build. So you can see here that it's already tried a build. This is the file and the build failed. But that's okay. We expected that to fail because it's not correctly configured for what we want. We need to make some changes to the YAML file it created to allow it to build and deploy successfully. So as we saw, we have this folder inside of our repo with our workflow files. And we saw that there was a few generated already, including the one that we just deployed. So some of these that you get will be from the original repo that we forked, but the one that we care about is the one that is named after the app service that we just created. And yours, of course, will be named after your own. So we're going to go inside of it and we're going to make some changes. So we're going to edit it. And there's some changes that we need to make. Now, if you see inside of the article, there is a gist that we need to go to. So I'll also share this in the description. But we have this new file that we need to change. So we can click Raw to view the whole file. We can then go ahead and copy the steps. So we need to go back in and make those changes. So inside of here, under the jobs, there are the steps. We need to change this from what it currently is to what it is now. And the reason that I put it in the gist to copy and paste is just because it then respects the indentation, which is so crucial in YAML. But as part of this, we've named our app MERN app. So we need to make sure this matches in the deploy app. So we have MERN app here. And then further down in deploy, you will see that it is called Node app. So what we want to do is change this to say MERN app instead. This then associates the build and deploy steps. So it will build it, then it will deploy it from with that name. So all we need to do now is commit those changes to file. So we can commit the changes. We can leave it as it is. Click commit. And that should trigger a new build. If we go inside of actions and take a look, you will see that it's now queuing that update. So we can even watch it. If you click build, it will give you the steps of what it's doing. So it's going through each of these and carrying them out. And we'll come back in a minute when it's completed and run through all those steps. Sometimes you'll find that when you deploy this for the first time and it runs, you will see this error about no credentials found. This doesn't actually mean what you think it means. In this instance, all you need to do to get around this if it happens is to go back to your repository that you forked and delete the workflow file that's got the other name that's main_something.yml. Once you delete this and run this again, you'll find that it will deploy successfully. And once that's done, you'll see a box here that will then give you a link to the URL that you set up for your website. If you then click that, it will go ahead and run, and you should see a website like this, like we saw before, which in your case should be empty, and then you can go ahead and start interacting with it. If you were to decide to add any data inside of Atlas, for example, then you should see that reflected in your database. If we have a look here, we can see we've got lots of databases already, but one of them is employees. If we go into records, we can see that document that we already showed in the app, but we could even go ahead and create a new one if we wanted to. So we could copy the contents of this, insert a document, choose to go to the JSON view, paste it in. It's going to have some funky formatting, but we can click that button to fix the formatting. We can then remove the ID because we want MongoDB to auto-generate that. We can then update it ourselves if we want to. Of course, normally why would you be doing this if you have a UI to do it? But just to show that they are linked, we can insert the data in. That will insert successfully. If we then go back to this and refresh it, you can see that I have been added there, just to show you that it is successfully linked to Atlas. So there you have it, how to really easily deploy a MERN stack application linked to MongoDB Atlas to Azure App Service. Drop a comment down below how you get on. If you enjoyed this video, don't forget to like and subscribe. And in the description below, you'll find all the links that you need to follow along. Happy coding!